Now we've mixed up things a little bit more. On the left side of the scale, not only do we have these identical unknown masses with mass x, these three blue things, we also have some of the 1 kilogram masses over here. We actually have two of them. So now we're going to try to figure out what x is. But before we even do that, what I want you to think about is a mathematical equation that can represent what is going on right here, that equates what we have on the left hand here to what we have on the right side of the scale right over there. And I'll give you a few seconds to think about it. So let's think about what we have on the left side here. We have three masses with mass x. So you could say that we have 3x over here. We have three x's. And then we have two masses of 1 kilogram. So in total, we have 2 kilograms, so plus 2. So one way to think about it, the total mass on the left-hand side is 3x plus 2. Three masses with mass x plus 2 kilograms. That's what we have on the left-hand side. Now let's think about what we have on the right-hand side. We just have to count these. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 blocks each have a mass of 1 kilogram. So the total mass right over here is going to be 14 kilograms. So we get, and we see that the scale is balanced. It's not tilting down or upwards. So the scale is balanced. So this mass, this total mass right over here, must be equal to this total mass. The scale is balanced. So we can write an equal sign. Let me do that in that white color. I don't like that brown. We can do it in that white color. Now, what I want you to think about, and you can think about it either through the symbols or think about it through the scale, is how would you go about, well, let's think about a few things. How would you first go about at least getting rid of these little 1 kilogram blocks over here? And I'll give you a second to think about that. Well, the simplest thing is, well, you could take these 1 kilogram blocks off of the left-hand side. But remember, if you just took these 1 kilogram blocks off the left-hand side, and it was balanced before, now the left-hand side will be lighter and it'll move up. But we want to keep it balanced so that we can keep saying equal, that this mass is equal to that mass. So if we're going to remove 2 blocks from the left-hand side, we need to remove 2 blocks from the right-hand side. So we can remove 2 there, and then we can remove 2 right over there. And mathematically, what we're essentially doing is we're subtracting 2 kilograms from each side. So we're subtracting 2 from this side. So on the left-hand side, we now have 3x plus 2 minus 2. We're just left with 3x. We're just left with 3x. And on the right-hand side, we had 14, and we took away 2. Let me write this. We took away 2, so we're going to be left with 12. We're going to be left with 12 blocks. And you see that there. The ones that I haven't crossed out, there's 12 left. And here you only have 3 of those x blocks. And since we removed the exact same amount from both sides, our scale is still balanced. And our equation, 3x, is now equal to 12. And now this turns into a problem very similar to what we saw in the last video. So I will ask you, what can we do to isolate 1x, to only have 1x on the scale while keeping the scale, or 1x on the left-hand side of the scale, while keeping the scale balanced? So the easiest way to think about it is, if I want 1x on this left-hand side, that's 1/3 of the total x's here. So what if I were to essentially multiply the left-hand side by 1/3? But if I want to keep the scale balanced, I have to multiply the right-hand side by 1/3. And so if we can do that mathematically, so right over here, I can multiply the left-hand side by 1/3. But if I want to keep my scale balanced, I also have to keep the right-hand side. I have to multiply the right-hand side by 1/3. And multiplying it physically, that literally means just keeping 1/3 of what we had here originally. So we would get rid of 2 of these. And if we want to keep 1/3 of what we had here originally, there are 12 blocks left over after removing those first 2. So 1/3 of 12, we're only going to keep 4 boxes, 4 of these little 1 kilogram boxes left. So let me remove all but 4. So we're going to move those and remove those. I have left 1, 2, 3, 4 here. And so what you're left with, the only thing you have left is this x. This x, I'll shade it in to show this is the one that we actually have left. And then we have these boxes. We have these 1 kilogram boxes. And you see it mathematically right over here, 1/3 times 3x. Or you could have said 3x divided by 3. Either way, that gives us, you could say that these 3's cancel out. That'll give you just an x. And then on the right-hand side, 12 times 1/3, which is the same thing as 12 divided by 3, is equal to 4. And since we did the same thing to both sides, the scale is still balanced. And so you see that the mass of this thing must be the same thing as the mass of these 4 leftover blocks. X must be equal to 4 kilograms.